Okay, students, in this video, we keep solving the monocentric model exercise. We go to letter G. Let's remember how is the question set. We have dwellings of 1,500 square feet. We also know that apartments have 15,000 of floor space per square block of land area. These two restrictions, what are telling you is that in this case, you are not allowed to change the height or the size of the buildings in this city. So you need to adjust via prices. The distance is measured in blocks. The income per household is 25,000, but we're going to be using units in thousands, so everything will be minus 3, taking the 3 zeros away. Y will be 25, and the commuting cost is 0.01. The consumer budget constraint is given by P times Q, where Q is how many feet of housing you have, times the price of that of each feet, and then we add a numerary that grabs everything else that the consumer buys. We call it breadth. And the utility grows if you have more C, and your utility grows if you have more Q. On the other hand, you have an income of Y minus the commuting costs, which are the cost per mile per block times how many blocks you need to commute. Okay, let's go to letter G. Now suppose that the population is 200,000, but that RA increases to 3. What this is telling you is that the farmers have more rent per block, per hectare, per mile, per square mile, or whatever. But the point is that in equilibrium, the rent from land in the city must be equal to the rent in land in the agricultural sector. Otherwise, they would start buying where it's more profitable until you reach the equilibrium. So the equilibrium right now it's 3. We established already all houses are the same size and X bar is fixed. Now we need to obtain the optimum consumption C star and the land rent function R. Okay, and finally the commuting cost of the furthest house. So let's do this. First of all, the population is $200,000, and we know that the area of a circle is given by pi times r squared. We already calculated these numbers, so we're going just to use the same number. 80 is the size of the blocks that we can fit, so that we have 200 people with houses in this city. So we have x equals 80. And this time we have r equals 3. So let's use the function of the land rent that we derived previously. And let's put 160 minus 0.1 times x minus 10c. In this case, we substitute instead of the r, the 3 that we know, that's the equilibrium rent. And instead of x, we use 80. And we solve for C star. So this is telling you what is the consumption bundle that is true when we have a rent of 3 and we have a distance of 80 blocks. In this case, we solve for C star and we get that that's 14.9. Okay, 14.9 is the level that we need C to be at. Now we go back to the land rent function. The land rent function is this one. We put r is equal to 160 minus 0.1 x minus 10 times C star. With this, we want to know how the rent varies under different distances. So we're just going to plug in the equilibrium number of C star and allow those other two things to vary. We plug 14.9, we simplify the equation, and we get this very neat equation that tells you how rent varies depending on how far or how close you are to the core. So you know that this is the distance that will, the size of the radius that will fit all these people. Therefore, the farthest house will be 80 blocks away. Okay, and with this information and knowing that r is equal to 3, we can derive C star. C star is plugged in the function, and now we know this relationship between x distance and rent, and this is the one of the most celebrated discoveries in urban economics, and it's very simple. So we have this graph. Originally, you remember, we had r equals 10 minus 0.1x. Now that we have this increase in land rent, basically the land rent function moved to the right. So it moved to the right, and now what happens is that they reach 3 when x equals 80. So this is the greatest distance, and in this case, the rent in the city will be 3, which is precisely what it's supposed to be. However, if you're closer to the core, the rent can be up to 11. And the rent will diminish until you get to the furthest house, which is just 3. And this is the land rent function. Compare your answers with those ones that we have had before. Oh, that's what we just did, but let me remind you, what did we have before in F? We had 14.9. We had a population of 255, and in this case we had a radius of 90. And when we substitute the 90 here, we got a C star of 14.9. So we plug this inside the formula and we get 160, and we get that r equals 11 minus 0.1x. So basically, in this case, the commuting cost was higher. Oh, did we calculate the commuting cost? I don't remember, but anyway, it's 80 times how costly it is per block. So it's 800. Okay, so for a minute, let me go back to the consumer budget constraint. The income is 25, so 25 minus the commuting cost. When we had a population of 255, the commuting cost was $900. Now we have a cost of $800. So that means that the consumer is also better off. Okay, now let's go to question I. Finally, and we're skipping question H because basically it says, let's suppose you have half the area, and well, basically your utility drops half. So let's go to an interesting question, question I. Focus on the inland city, in other words, the circle, and suppose the zoning authority imposes a building height restriction. Now, this restriction limits housing square footage per block to 7,500. So this is half the previous amount. The cost of building materials per square block falls from 90 to 43. And the reason they do this artificially, it's because we just had half of the construction, but not half of the cost, because we are experiencing diminishing returns. I mean, it's not that huge change between the half of 90 is 45, right? So in this case, we have a cost of 43. Now find the new value of x bar and repeat D and E. Okay, so let's go. In this case, we need to calculate what is the size of the city that we need, because now we have restrictions in the size of the blocks. Before, we had 15,000 square feet of housing, and each apartment had 1,500 square feet. And when we divided 15,000 by 1,500, we had 10. In this case, we have 7,500 divided by 1,500. That's 5 homes per block. Therefore, we need to accommodate enough space for 200,000 people. Oh, did I mention that in every household there's one person in this silly model? Okay, anyway, so you need this many households. So this is the area of the city in terms of square blocks, okay? Now, if the city has 200,000 households, how big must X bar be in order to fit this population? So we use this equation, 5 pi times X bar square must be equal to 200,000. From here, we solve for X bar, and we divide both sides by 5 pi, and then we get the square root, and we get 112.8. So this is very close to 113. We're going to suppose that we have a radius of 113. Anyway, we do need a radius of 113 because, this is blocks. And if you have 112 blocks, you won't make it. So you need 113 blocks. Now we have this restriction. Before, we used to have a profit per square block that was 15,000 minus 90 minus the rent. But now we have a profit of 7,500 times the price they pay minus 43, which is the cost, minus the rent. So we have this constraint. Since in equilibrium the developer has zero profit, then it must be the case that R is equal to all this. R is equal to 7,500 P minus 43. And first we focus on the consumer problem using budget constraint that X bar is 1,500. So this is the consumer constraint. If you remember, this is the consumer constraint. And we are substituting, instead of X, 1,500 equals 25 minus 0.01x. And from here we say, okay, what is P? What is the price per square footage? With this P, then we can go to the problem of the developer. So we derive P from the consumer. Okay, this is what the consumer will pay. Now let's go to the developer. I copy here the value of the consumer. The builder restriction is 7,500 times P minus 43 minus R equals zero profits. So that means that R must be equal to 7,500 P minus 43. And instead of P, I'm going to plug this number. We put it here, so we have this equation. And I'm going to simplify it, and the easiest way is to divide 7,500 by 1,500. That's 5. So we have R is equal to 2, so we put the 2 already, equals 5, open parenthesis, 25 minus 0.01x minus C star, closes parenthesis, minus 43. And now we have everything in terms of C star and X. I'm just solving for C star because we already know the value of X. So I subtract 2 from both sides. I add 43 on both sides. Oh, and 125 minus 43, so that's 82 minus 0.05x minus 2. We divide everything by 5. And we get that C star. And we remember that X was given by 113 from this equation, right? So using X equals 113, we get that C star is 80 minus 0.05 times 113 divided by 5. And when you plug that into your calculator, you get 1487. So let's put everything together. What we are aiming is to obtain the land rent function, a function that makes you know how much rent you obtain from different distances. And in order to do that, we obtained right now, right here above, the function R equals 82 minus 0.05x minus 5 C star. We got C star equals 1487. And now what we can do is plug C star on the function and see how does the rent vary with different distances. So we go back to the original, the one without the X and R solved. And we learn from simplifying this equation that R is equal to 7.65 minus 0.05x. When distance is 0, when you're writing the core, your rent is 7.65, and when you're the farthest possible from the core, 113, your rent is 2. Graphing this, we have this line. So when the distance is 0, the rent is 765. And when the distance grows all the way to 113, the rent is 2. Now, what happened is that there's no restriction in how much the city can grow. We still have the square footage of the household, but in this case, the city had to extend further than before. This is bad news because the revenue generated of each acre of land is lower than before. Here, the closest to the core gives the people, the developers, 7.65, while before they had a 10. And the reason is that it contains fewer square feet of housing per block, per mile square. Now, in order to get land rent up a level where enough land is bid away from farmers, R must rise, which in turn requires a lower C star. So the price per square footage must rise. People then are worse off with the restriction. They have a lower C star
And they have a higher X.